On a quiet August night in 1977, something in deep space screamed for 72 seconds, then fell silent forever. The scream was not sound. It was a radio burst so clean, so intense, that a computer printout would later earn a single handwritten word, "Wow." The receiver sat in rural Ohio, on a patch of land that looked ordinary by day and almost prehistoric by night, the Big Ear radio telescope. If you only remember one fact, remember this: the signal lasted exactly as long as the telescope could hold it in view, and it never repeated. That combination still haunts SETI. A one-time event can be real. A one-time event can also be a mistake. The wow signal sits between those two doors. This is the full story of those 72 seconds, what the instrument was designed to catch, what it recorded, and why the silence that followed still matters. Big Ear was not a postcard dish. It was a huge, flat-looking radio telescope operated by Ohio State University, built for large-scale surveys of the sky. Its job was patient and industrial: sweep the heavens, collect faint radio energy, and turn the universe into columns of numbers on paper and tape. In the mid-1970s, that industrial machine was drafted into something more ambitious: the search for extraterrestrial intelligence. SETI logic at the time was elegant. If a distant civilization wanted to be noticed, it might choose a frequency that every radio astronomer already understands. That candidate was the hydrogen line near 1420 MHz, the natural radio whisper of neutral hydrogen filling the galaxy. Hydrogen is everywhere. Its spectral line is a cosmic common tongue. Point your antenna there, and you are listening where nature already broadcasts. So SETI programs parked near that line, looking not for random noise, but for a narrow, persistent signal that nature struggles to forge by accident. Big Ear's SETI effort was not a Hollywood control room packed with flashing alarms. It was paper, tape, and late nights of methodical review. The telescope watched strips of sky as Earth turned. A source that stayed fixed on the celestial sphere would drift through the beam for a limited, predictable window. That geometry is crucial. Big Ear did not stare forever at one patch. A true sky source would rise in the beam, peak, and fall away in a known pattern of time. On August 15, 1977, the survey captured a burst of intensity that jumped off the page of the computer printout. The intensity sequence was coded as 6EQUJ5. In the telescope's notation, those characters mapped a rapid climb to an extraordinary peak. Days later, while reviewing the data, astronomer Jerry Ehman saw the pattern, circled it, and wrote one word in the margin: "Wow." That word was not branding. It was an involuntary reaction from a trained scientist who knew what ordinary radio interference usually looked like. The timestamp and coordinates placed the event in a region of the sky in the constellation Sagittarius, far from the casual flutter of daily terrestrial chatter. Even more striking, the signal appeared in only one of Big Ear's 2-feet horns. A source fixed in the sky should follow a specific horn sequence as Earth rotates. The dual horn design was a built-in filter. Many local glitches would light both channels or fail the expected transit pattern. This event did not behave like garbage. It lasted about 72 seconds, matching the time a celestial source would spend crossing the telescope's beam during that survey. It was narrowband, unmodulated, and intense. In plain language, a clean spike of radio energy at a frequency SETI had deliberately chosen to watch. Ehman later described the moment's shock. No known terrestrial source, by itself, seemed to explain the intensity and cleanliness of what the paper showed. To understand the obsession, you have to understand the checklist SETI researchers carried in their heads, and how many boxes this signal seemed to tick. First, frequency. Sitting near the hydrogen line made the event land inside the exact band where deliberate beacons were expected to hide in plain sight. Second, narrow bandwidth. Natural cosmic processes often smear energy across frequencies. Engineered signals can be sharp, almost surgical. Third, duration matching beam transit. A source on the sky should not stay in the beam forever. 72 seconds fit the telescope's geometry. Fourth, single horn appearance. That detail reduced the odds of some forms of local electronic noise that would contaminate both horns. Fifth, intensity. The signal rose and fell with a profile consistent with the source sweeping through the antenna pattern, not a random click on a cable. None of those points prove aliens. Together, they explain why careful people refuse to shrug. The wow Event looked like the kind of anomaly you are supposed to chase. In science, extraordinary claims require extraordinary evidence. But extraordinary candidates also require extraordinary patience. One printout is a beginning, not a verdict. So the next step was obvious and brutal. Look again. Point better instruments. Wait for a second pulse. Without a repeat, the mystery stays open. Follow-up observations try to catch the same source again. Teams return to the coordinates with better sensitivity and different telescopes. The Very Large Array and other instruments searched the region. The sky stayed quiet. The spike did not return on command. That silence is not proof the original event was fake. It is proof that the universe does not schedule encores for human convenience. Big Ear itself continued work, but the unique combination of timing, intensity, and beam geometry never reappeared in the same dramatic form. Researchers debated terrestrial candidates, aircraft, satellites, military transmissions, reflections, equipment glitches, and odd propagation effects. Some explanations fit pieces of the puzzle. Few fit all of them at once without stretching. The dual horn geometry and beam transit duration kept fighting easy dismissals. Later analyses revisited the original printout, coordinates, and frequency. Papers proposed comets, hydrogen clouds, and other natural mechanisms. Natural hypotheses matter. A good SETI program must be harder on itself than on the aliens it hopes to find. Wishful thinking is not a detection. Yet even critical reviews often end in the same place, interesting, unresolved, and still short of a closed case. The data remain thinner than the legend. Ehman himself stayed cautious in public memory. Fascination is allowed. Certainty is not free. The margin note was excitement, not a certificate of contact. Popular retellings compress the wow. Signal into a cartoon, either first contact or pure nonsense. Real radio astronomy lives in the uncomfortable middle. A single non-repeating event can be astrophysically real and still not be a message. Reality is under no obligation to be conversational. Likewise, a non-repeat does not automatically mean local interference. Transient phenomena exist. Rare is not the same as impossible. The documentary version people want is a smoking gun with a second pulse, a decoded pattern, and a press conference. History delivered a margin note and decades of quiet. That quiet is exactly why methodology improved. Modern SETI builds multi-site confirmation, rapid follow-up networks, and filters that demand the signal survive cross-checks. In other words, the wow event became a training star. It taught the field what a candidate looks like and what a confirmed detection still requires. Today's arrays can stare deeper, process faster, and coordinate globally. The bar for claiming intelligence is higher because the instruments are better. So when people ask, did we almost meet someone, the honest answer is colder. We almost met a standard of evidence, and the universe declined to finish the sentence. Decades later, the wow signal still fuels SETI culture because it is the perfect unfinished story, sharp enough to refuse dismissal, thin enough to refuse belief. It sits in the same mental museum as other scientific almost events that force better questions even when they withhold clean answers. Big Ear is gone now, dismantled and replaced by ordinary landscape. The machine that caught the spike cannot catch it again. That absence sharpens the legend. The original hardware is history. The printout remains a relic of a night when the sky looked briefly deliberate. Whether the burst was an unknown natural flare, a rare terrestrial path, or something stranger, it proved one operational truth: listening is an act of patience measured in years. SETI is not a single eureka. It is a long vigilance against noise, hope, and the human urge to turn one anomaly into a destiny. The word wow was human. The silence after it was cosmic. Between those two reactions lies the real drama of the search. New surveys keep watching the hydrogen neighborhood and far beyond it, with software that would have seemed like science fiction in 1977. If another candidate appears, it will face a harder court, simultaneous telescopes, rapid alerts, and demands for a repeat that can be shared, tested, and survived. Until then, the wow signal remains a 72-second question mark hanging over Sagittarius, a reminder that the universe can still surprise us once, and refuse to explain itself twice. So the final open question is not only what caused it. It is whether we will be ready technically and psychologically if the sky ever writes a second line. One burst made history. The next one, if it comes, will have to make proof.